There are two types of fault that you're likely to get with electrical circuits: an open circuit or a short circuit, and the two are very different. Let's take a look at this. We've applied 12 volts to the track. We've put a locomotive on the track. The motor in the locomotive is turning because it's drawing current from the supply. The current is passing along one track, through the motor, and back to the power supply through the other track. What happens if we break the circuit here? Well, immediately the motor stops, because there has to be a continuous circuit for the current to flow through the motor so the motor turns. So if you break the circuit here, the motor stops, but in just the same way, if you break it here, the motor stops. If we break it here though, it makes no difference at all. Or here, because the current can still flow through the motor. So finding where the open circuit is, if you've got a problem with track or point or somewhere, is really straightforward. You'll find that the locomotive runs, but when it stops, there is the brake. The brake is something to do with the feed from the power supply to the locomotive. It may be the track, it may be the wiring up to that section of track, but nonetheless, that's where the problem's occurring. Now, where an open circuit was a break in the circuit, a short circuit is a small piece of wire, a strand of wire, or maybe a blob of solder that actually connects together both sides of the supply. Now, if we put a short circuit on here, then the electrical current will take the easiest path, which is straight through the short circuit. So current will flow along the track, down through the short circuit and back through the track to the power supply. No current will flow through the motor, and in fact the short circuit will force the power supply to produce a great deal of current. Now, sometimes the power supply will get hot, but more often than not these days there's a protection circuit within the supply that will cut off the supply if the current gets too great. This is particularly true with DCC circuits. They're extremely sensitive to short circuits. So initially then, the short circuit here will draw current and stop the motor turning. After that, a trip comes into play, and that removes the current completely from the circuit until you can find out what the problem is. If we move the short circuit to here, then exactly the same thing happens. Again, the current finds the easiest path, which is through the short circuit, bypassing the motor. So now we haven't got that nice convenient situation where we can identify where the short circuit might be. Okay, let's apply some of those principles now to a layout. We'll keep it a simple layout of this oval. We'll have a common return which will link to both sides of the oval, and we'll split it into 4 sections. We'll bring a red lead out of each section and bring it down to a section switch. For convenience, we'll label each section 1, 2, 3 and 4, and we'll label the switches just the same way. Controller 1 will be connected to one side of the switches and controller 2 to the other side. So that's our layout. So now we've got our circuit, let's simulate a fault. Let's assume that everything works okay except that nothing runs on section 1 of the track. Now it should do. Looking at this wiring layout, we've got the common return connected up. We've got the yellow wire coming out of controller 1 going up through switch 1 up to track section 1. Controller 1 is set at maximum, so the locomotive should run, and run pretty fast. We'll test it not with a locomotive, but with a bulb. Now one side of the bulb will connect to the common return. The other one we'll use as a test probe. First of all, let's connect our test end of the bulb onto the track itself. Well, the bulb looks pretty dead here, as you'd expect. The next test point is going to be the next stage towards the controller. So we'll go to that connection where the track is connected to the wire. No, nothing there either. So we'll come a stage further down to the top of switch number 1. Still nothing. But if we go to the other side of switch number 1, the lamp lights up. So we've got our 12 volts there, we just don't have it on the other side of the switch. This tells us then there's something wrong with the switch. Either the wiring around the switch, something's possibly dropped off the switch, or the switch itself could be faulty. Check that out, replace the switch if necessary, and everything will be fine. Now you can use just the same principles for finding any fault on any section of the track. Use a logical process working back from the track until you find the voltage that you need. Now finding a short circuit will need a different approach. What we have working with us though is that most controllers have some sort of a trip or a cutout. And we can use this trip as an indicator of where the short circuit is likely to be. Let's first of all show these trips as little red lights on each controller. Power up the layout and the trip blows on controller 1. So we have an overload somewhere beyond controller 1 itself. The first thing to do is to try and limit the area where that short circuit appears. So let's switch over to controller 2. Switch the circuit on again. We've still got overload. So our problem lies somewhere on the layout that's beyond both controllers. The next thing to do is to isolate the fault further, so we can isolate each section of the track. This is a huge benefit. Even if you have DCC, it's a huge benefit of having track sections on the layout. So if we first of all isolate all 4 sections and then turn each one on in turn. Section 1's okay. Section 2, that's fine too. But when we switch section 3 on, the trip light lights up. So our fault is somewhere on section 3 of the layout. If there's anything standing on that section, remove it. Locomotives, rolling stock, anything at all that might itself cause a problem. If the trip still lights now, then the fault has to be in the wiring up to that section or something lying across the track itself. Look particularly at points, because points are where the black rail and the red rail run very close to each other, and it's quite likely that you'll get a short somewhere around there. If the trip doesn't blow, with all the rolling stock off, then the problem is somewhere in the rolling stock. So put them on one at a time back on the track and see which particular item is causing you the problem.